The objectives of this lab are 1. To determine the relationship between current and voltage, and 2. To reproduce Ohm's law. We will revisit these in a little bit. Let's go over some terminology and some background knowledge of circuits. Let's go over some terminology. This lab includes 3 new instruments, an ammeter or rheostat and a potentiometer. An ammeter is an instrument used to measure electric current. A rheostat is an instrument used to control a current by varying resistance. A potentiometer is an instrument used to measure the electromotive force or potential difference between 2 non-terminal points. A voltmeter can replace a potentiometer in this lab. A voltmeter measures voltage between 2 terminal points. Now, what is electric current? Electric current is defined as the rate of charge flow. That is why 1 ampere, the unit of measurement for current, is equal to 1 coulomb, the unit of measurement for charge, over seconds, the unit of measurement for time. Now, let's discuss conventional current. Well, what is conventional current? Conventional current is defined as moving in the same direction as the positive charge flow. Therefore, in metals where electrons flow, conventional current is in the opposite direction of the movement of electrons. Nevertheless, the magnitude of electric current is the same no matter the way the current is theoretically represented. However, electric potential and current will change sign, positive or negative, regarding the placement of positive and negative wire caps on the potentiometer, ammeter, or voltmeter. This is because current is equal to voltage over resistance, or Ohm's law. Therefore, voltage is equal to current times resistance. If current changes direction, sign, the potential difference will change sign. However, the magnitudes will remain the same. The diagram below represents the direction of conventional current defined as the red arrows and the flow of electrons in blue arrows. These 2 diagrams represent the circuit we will create in this lab. The left image uses a potentiometer to measure potential difference, and the right image uses a voltmeter to measure potential difference. At this moment, pause the video and copy the diagrams. Then draw the direction of conventional current and electron flow on both diagrams. Check your answers on the following slides. Now, you might ask, why do I need to put wires where it says positive and negative on both the ammeter, voltmeter, or potentiometer? Well, the spots represent where conventional current should enter. The negative spots represent where conventional current exits. Flipping the wires will result in a change in sign of the current or reveal inconclusive data. Another question you may have is, why should an ammeter be connected in series with a resistor? Well, ammeters record the current at a specific point in a circuit. Ammeters are usually placed after a resistor to find the current that traveled through the resistor due to the potential difference. In addition, current remains the same when placed in series with resistors. For more information, reference the lab on series circuits. Also, why should a voltmeter/potentiometer be placed in parallel with a resistor? Potential difference is defined as the voltage change between 2 points. Connecting the wires in series with the resistor will show no potential difference because the point of entrance and the point of exit are unaffected by a resistor. For more information, reference the lab on parallel circuits. Now let's get to the fun stuff. Let's go over the materials for this lab. You will need a battery, usually 6 volts, a switch, a rheostat, an ammeter, a resistor spool, and a potentiometer or voltmeter. Let's put this circuit together. At moments, I will pause the video and explain what is going on. Let's begin. The first step is place an alligator clip from the negative side of the battery to one spot on the switch. The placement on the switch does not matter because a switch just acts as a modified alligator clip between 2 spots on the circuit. Next, we take an alligator clip from the opposite side of the switch to the bottom cap of the two-capped end of the rheostat. Then we take an alligator clip from the positive end of the battery to the other end of the rheostat. This end has only one cap. Then we take an alligator clip from the top cap of the two-capped end of the rheostat to the negative end of the ammeter. Then we take an alligator clip from the positive end of the ammeter to the negative end of the resistor spool. Then another alligator clip is used from the positive end of the resistor spool to the single capped end of the rheostat. At this point, there should be two wires on this cap. The last step is to take the positive end of the potentiometer to the positive end of the resistor spool, and the negative end of the potentiometer to the negative end of the resistor spool. And now you have completed your circuit. Alright, let's return to the objectives of this lab. 1. To determine the relationship between current and voltage, and 2. To reproduce Ohm's law. Let's go over the background stated in the lab. Ohm's law states that if the temperature of a resistor remains constant, the electric current flowing through the circuit is directly proportional to the applied voltage and inversely proportional to the resistance of the circuit. Therefore, current is equal to voltage over resistance, resistance is equal to voltage over current, and voltage is equal to current times resistance. At this moment, steps 1 through 3 have been completed. Now we'll perform the following for 3 different resistances on the resistance spool. This step can be done by moving the alligator clips from the positive and negative end of one of the resistors on the spool to another. Let's start step 4. Slowly move the slider across the rheostat until the ammeter registers a small current at a mark on the ammeter. 5. For this position, measure and record this current and voltage. And 6. Increments of the current 7 times, recorded both the current and the voltage in the table below. Data collection. In Table 1, you will record the values for voltage across 3 different resistors, as well as the value for current that flows through the resistors. A sample set of data can be seen here. Data analysis. After we will calculate the resistance of each of the 3 experimental resistors. 1. Sketch the graph of voltage versus current. And 2. The resistance is the slope of the line of the graph voltage versus current. Due to Ohm's law, current is equal to voltage over resistance, or resistance is equal to voltage over current. The following is a best fit line for resistor 1. The slope of the line is 2 ohms, therefore the resistance of the resistor is 2 ohms. The following is a best fit line for resistor 2. The slope of the line is 1.5 ohms, therefore the resistance of the resistor is 1.5 ohms. The following is a best fit line for resistor 3. The slope of the line is 1 ohm, therefore the resistance of this resistor is 1 ohm. At this time, pause the video and discuss the answers to these 5 conclusion questions in small groups. The answers to these questions can be seen on the next slide. Now pause this video again and answer these 3 application questions with your group. The answers can be seen on the following slide. Thank you for participating in this online lab. I'll see you next time.